Thanks for being here. My name is Josh, and I'm a software engineer at Oracle. And today I'm going to be talking about storing JSON in the autonomous database. If at any point during my presentation you have questions, feel free to ask them in the Q&A part of the meeting. We've got a couple of engineers from the JSON database team standing by to answer questions. I also put my email address on this slide. You're very welcome to email me directly with questions during or after the presentation as well. So let's get started. Okay, so I've got a few slides I'm going to present, and then pretty quickly I'm going to jump into a demo where I'm going to show how to create an autonomous database, and then I'll show how JSON can be stored natively in the autonomous database. And then I'll show how JSON stored in the database can still be queried using SQL if you want to. And then to finish up, we'll load a public JSON dataset into a collection and show how that can be analyzed using a machine learning notebook. So as you may have heard during the keynote, a big advantage of Oracle Database is that it supports multiple data models and multiple workloads over those data models. So you can have all these different data types like relational, document, XML, JSON, spatial, and so on. And then you can access, process, and analyze that data in a variety of different ways. And today I'm going to be focusing on just one of these data types, and that's JSON. And specifically, we're going to be talking about JSON in the autonomous database. So the autonomous database is the managed version of Oracle Database in the cloud. And today at this event, we're announcing a new version of the autonomous database that we're calling the Autonomous JSON Database, or AJD for short. So AJD is intended for building scalable, interactive applications and microservices that primarily need to store JSON data. As you may be aware, JSON continues to grow in popularity as a storage format for application development. It's easily consumed by most programming languages. It tends to be a pretty good representation of application objects. It's also schema flexible, so that your application can evolve to store new types of information easily. For example, if you're building a web app and you have a form and you want to add a new field to capture some new piece of data, with JSON development, you can often do that sort of thing without modifying your backend data definitions. And when it comes to interacting with AJD, we've added simple document APIs that make it easier than ever to persist your application objects as JSON. So using these APIs, you can build up an entire app without ever having to write a single line of SQL if you don't want to. And AJD provides all of the same benefits that are typically associated with NoSQL document stores. For example, you might be surprised to learn that it's elastic, meaning that you can scale up or down the compute and storage capacity of your database as you need to. You can even enable auto-scaling so that the compute goes up or down based on the current workload. We've also seen that these databases, NoSQL stores, advertise that they can maintain single-digit latency at scale. And so what they mean by this is that for small reads and writes, they can keep the response time of those requests under 10 milliseconds, even when a lot of requests are going on in the database at once. So AJD can also do this. It can maintain single-digit latency at scale. But the thing is, it does this without sacrificing the consistency or durability of your data. For example, with AJD, if you've got a query that's returning documents, it's not going to start returning the same document twice just because other people happen to be writing data to the database at the same time. If you read the documentation of some of these other stores, they call out that things like this, situations like this can happen, things that might be difficult to anticipate or test for in an app. These NoSQL stores are often also thought of as low cost. Everything that I'm going to show you and demo today is available in the always free tier of the autonomous database. So you can store JSON in the autonomous database for free forever. You're not going to pay a thing unless you explicitly decide to upgrade out of the free tier. And AJD in particular is designed to be price competitive with these other databases. And we'll see what that means in 2 slides. But even so, the autonomous JSON database is much more than just a simple document store. It provides a rich set of features that you're not typically going to find in NoSQL stores. So first and foremost, it's managed and autonomous. So things like installation, patching, tuning, and backups, all of that happens for you automatically and allows you to spend much less time setting up and managing databases. And you get to spend more time, developing your app and doing the fun stuff. We also, an advantage we have is that we have full SQL support for natively stored JSON. So you don't have to use SQL if you don't want to, but it's there. And SQL is a powerful tool for doing analytics and reporting, even over JSON data. The other advantage that SQL gives you is that it allows you to create real-time relational views over your natively stored JSON. So if you have a tool or an app that can only consume relational data, you can create a view so that it can consume your JSON data and not really be aware that it's JSON. So we have a bunch of other advantages like full support for ACID transaction, advanced security features. We have Apex for doing low-code application development over JSON. We've got ORDs, so you can a framework so you can build up REST services over your data. All of this is available as soon as you create your database. There's no installation or configuration required. It's all just ready to go. And then finally, if you start out with AJD and you're storing JSON, and at some point you figure out that I really need to store other types of data as well, you aren't locked in a corner at that point. With a single click, you can upgrade your database from AJD to a full ATP instance. So AJD is part of the autonomous family. In particular, it's most similar to ATP, the transaction processing database. In fact, all of the JSON features that you're about to see that are available in AJD, they're also made available in ATP, and they have the same performance characteristics. So what's the difference? The difference is that in AJD, you're restricted to just 20 gigabytes of storage for relational and other types of data like XML. You can scale up your JSON as much as you want to, but for these other types of data, you only get 20 gigabytes of space. But because of this restriction, we offer AJD at a much lower price. Before I begin the demo, one important note here is that if you are working in the free tier and you want an always free database, we don't have an explicit JSON option in the free tier. So you would just pick ATP there since it's already free and it has the JSON features. If you start with a free ATP and you're doing JSON, there's an option that you can select at some point to upgrade that instance to AJD if you want to. Okay, so that concludes my presentation. So now I'm going to start a demo. So to start the demo, I'm going to log in to Oracle's Cloud Console. And I'm going to show you how to create a database. So I'm clicking on this navigation menu up here on the left, and I'm clicking on Autonomous JSON Database. And now I'm going to click on this big blue button here that says Create Autonomous Database. And so this page asks a fairly minimal set of questions about the database that you want to create. So here it's asking about the workload. This is where you could select transaction processing or JSON. Then notably, it's asking here about the compute and storage capacity I want. These are just initial settings. After you create the database, you can change these at any time. You can decide if you want to enable auto-scaling or not. And then you pick an administrative password. And then if I were to click Create Autonomous Database here, it would take about a minute when I've timed it. And then that database would be ready to go. But for the demo, I have one already created, this one here, DemoDB. So the only thing that I've done to this that I'm not showing you is I've created a non-administrative user to connect to, but otherwise it's basically like a brand new database. And so the first thing that we're going to do here is we're going to log into a tool called SQL Developer Web. Now, SQL Developer Web is a browser-based tool to execute SQL and other commands against the database. So I've already got that open here. And the first thing we're going to do in SQL Developer Web is we're going to run a SOTA command. So SOTA stands for Simple Oracle Document Access. It's basically the name of our JSON Collections API. It allows you to work with your data as a simple collection of JSON values rather than a table with columns and rows. So the first SOTA command I'm going to do is SOTA list. And this is going to list the collections in my database. It looks like I'm logged out here, so I am going to have to re-log in. Okay, let's try again. All right. So it says there's no existing collections. So let's create one. So I'm creating a collection called emp for employee. We're going to create a collection of employee JSON objects. And so it says successfully created. Now I'll do SOTA again, SOTA list. And now it says I have one collection named emp. So let's insert some JSON into this collection. So the first JSON object that I'm going to insert is for an employee named Blake. Blake is an intern and makes $30,000. So if I click this green button here, it says inserted successfully. Let's do a couple more. So this next employee is named Smith. Smith is a programmer, and Smith makes $80,000. So let's insert Smith. Now let's do our last one here, for now at least. The next one is Miller. Miller is also a programmer, and she makes $90,000. Okay, so we've created a collection, and we've inserted 3 JSON objects into it. So now let's try and get some of this data back out. So I'm adding -f to a SOTA get command, and F stands for filter. And I'm adding an example document here. These are sometimes called queries by example. Basically, the idea is you give a small JSON object that looks like the data you want back. So here, if I run this, it's going to give me back values where name is equal to Miller. So if I run this, you see I only get one document back. And these can get a bit more complicated. So I'm going to now add the greater than operator here. So for salary, I'm saying $GT 50,000. And what this is going to do is it's only going to return documents back where salary is greater than or equal to $50,000. And so here I get back just 2 of our 3 documents, the 2 programmers, Miller and Smith. Unfortunately, the intern, Blake, doesn't make more than $50,000, so it wasn't returned by this query. And so this is SOTA from the command line. It's also available in SQL CL. But next we're going to show how SOTA can be used from REST services and then from a Java program. We also have drivers in other languages as well for collections. We've got one in Node.js, Python, C, PL SQL. Unfortunately, I don't have time to show all those today. But before I move on to showing REST services for SOTA, I want to hit this refresh button over here, this table list. And so now what I have is a table it's showing me with the same name as my collection. So the thing I want you to realize is that even though we're working with this data as a simple collection of JSON values, that it's backed as kind of a persistent store by a table with a JSON column. And this is important because it allows you to still use SQL over this JSON if you ever need to. And we'll come back to that in just a few moments. But for now, we're going to move on and show how the same data that we just inserted can be accessed using REST. So I'm coming back here to this Cloud Console, and I'm now going to open up the Database Service Console. And on the left here, I'm going to click on the development link. And now in the lower right-hand corner of this page, there's a card that says RESTful Services and Soda. So I'm going to click Copy URL. And now I'm going to take this URL and I'm going to go to this program I have called Postman. Postman is a third-party app. We don't make it at Oracle. As far as I know, we're not even affiliated with Postman. But it's just a nice way to submit REST requests against the service. So I'm going to take that URL I just copied and I'm going to paste it in here. And I'm going to add a few more steps. So I'm going to add the user step, and then soda, latest, emp, and then I'm adding this parameter at the end, fields equal value, which just tells it I just want the values back and not the keys of these documents. Okay, so now I'm going to add in my username and password and click this send button. And so now down here in the result, I see a result containing those same three employee JSON objects that we just inserted. So let's insert a fourth one. So I'm going to change this request to a post and delete this parameter at the end. But this time I'm going to add a body. And I'm going to add a fourth employee. So our fourth employee's name is Clark. She is a manager that makes $100,000. So if I click send now, it gives me a response indicating that Clark was inserted into this collection successful. So the Soda REST services are really a full-featured API. It supports all kinds of different operations like pagination of results. You can do updates. You can do filtering with query by example. All kinds of things are available here. But we don't have time, unfortunately, to go into all of that. So at this point, I'm going to move on and show how we can access this same data from a Java program. So now I'm opening up Eclipse. Eclipse is a IDE. It's a tool for writing Java. It's running on my laptop here, so I've got this Java code on my laptop. And this first example that we're going to run is going to pull these employees that we just created out of this collection. So at line 21 here, we're opening up the employee collection. And then at line 24, I'm creating a cursor to iterate the contents of the collection. And then within this loop that's iterating through this cursor, it's accessing the current document as JSON object. This is a standard API in Java for representing JSON data. And then I'm printing out the name, salary, and job title of these employees. So I'm going to click this green button up here. And it should show me the result down here in a moment. So here we have 4 rows for each of the 4 employees that we've inserted so far. Now let's insert our 5th employee, but this time from Java. So here I'm opening again, this example starts out the same way. I'm opening up this employee collection. And this time I'm building up a new JSON object for King. Now King is the president and she makes $200,000. And the interesting thing about King is that she has an email address, unlike the other 4 employees that we've added so far. And that's okay. That's the nice thing about JSON is that there's no requirement that all the values have to have the same set of key value pairs. So King can have an email, the rest don't, and that's fine. So then it takes King and inserts it into the collection. So if I run this, we get a message indicating that this new employee was inserted successfully. So these Java examples are pretty simple. If you want a more realistic example of how you might build an app or a microservice using Java, we have MooShop. So MooShop is a demo app that runs fully in Oracle's cloud. It's basically an e-commerce site that sells pet food and things related to cats. And it's built up using a modern microservice-based architecture. So this site is built up using all these different services that use various different languages. But if you look at the shopping cart service, the service that manages the shopping cart, That's actually built using JSON collections and the autonomous database. And all of this app is open source. So you can go to GitHub and see all the source code for this app. You can even deploy it within your own cloud account. So if you want to see one way that you might build a microservice using Java and JSON and the autonomous database, you might want to take a look at this. It's a bigger, more realistic example. Okay, so at this point, I want to go back to SQL Developer Web and call your attention to the fact that at this point, we've created a collection, we put data in it, we've gotten data back out. At no point have we written any SQL so far. So you can build up an entire app without having to use SQL if you don't want to. However, SQL is often a powerful tool for doing analytics and queries and joins over your data. So at this point, I'm going to show how we can still evaluate SQL over this collection that we've created. Okay, so the first thing I'm going to do is I'm just going to select the JSON document column from this table and see the JSON that we've inserted so far. So down here in the result now, we see a result with one column, which is the JSON document, and the 5 employees we've inserted. You may notice that I added a JSON serialized function here. The reason is that when you insert JSON into a collection, we store it internally using a highly optimized binary representation of the document. We don't just store it as text. And this allows it to be ingested, retrieved, and queried and updated very efficiently. So if I want to get it back out in a form that I can see that looks like JSON, I have to add back the JSON serialized function. You can also take the attributes in the JSON objects and you can project them out. So here I'm dotting in using the simple dot notation to get the name, the job, the salary, and the email of these employees. So now I see 5 rows, but this time I've got a column for each one of these keys. And the nice thing about our SQL support over JSON is that there's absolutely no restrictions on the type of queries that you can run. You can do any kinds of joins or aggregations, any kind of join predicates. You can have queries that access JSON, XML, relational, all on one query. Anything goes. So let's start slow. And I'm going to insert or do a group by query over this JSON. So I'm grouping by the job title, and I'm going to project out the job title and the number of employees that have that job title. So if I run this, we see here that I've got a single intern, a president, 2 programmers, and a manager. So this employee data in this simple little data set is nice for showing the kind of mechanics of using collections. It's not very overwhelming, but it's not so great to show interesting analytic queries or reporting over data. So for the final part of the demo, I'm going to load a public data set into a collection. So the data set we're going to load comes from City Bike. City Bike is a company that operates bike sharing stations all over New Jersey and New York. And we aren't affiliated with City Bike, as far as I know. But the reason we're using them here for the demo is they just did a really nice job of exposing data about these 900 bike stations that they operate as JSON. So specifically, we're going to load 2 different data sets from them. The first one's called station information, and it's a file where each line of the file has a JSON object on it. And there's about 930 lines, and each line represents one of the stations. And it records information like the name, the location, the capacity of the station, and so on. The second data set is called station status. Now, again, this is a file with 1 JSON object on each line. But here, this is representing a station at a particular point in time. So there might be multiple lines here for each station, and it's summarizing at different points in time the state of that station. Now here it's recording things like the number of bikes that were available at that point in time. So for every JSON object on this side, it has multiple joining objects based on station ID on the right-hand side. And so we're going to take these and upload them to the Oracle Object Store. And then from there, we'll bulk load it into a collection. So I'm going back to the Cloud Console here, and I'm going to go to the object storage. So under object storage, I'm going to create a bucket. I'm going to call it bikes. And I'm going to make this bucket public just so I don't have to specify credentials. And then I'm going to upload my 2 files to this bucket. I've got them on my desktop here. And the bigger one's at just 5 megabytes. I kept it kind of small so that you could upload it without too much fuss. And so now it shows my files are there in this bucket. If I click on the details here, you can see that each of these files has a URL associated with it. And this is the URL we're going to reference in a second to bulk load this into a collection. So now I'm going back to SQL Developer. And I'm going to call the copy collection. So as I explain this, I'm going to run it because it takes a moment. So I'm calling copy collection here once for each of these files. And so copy collection takes 3 arguments. The first argument is the name of the collection you want to create. The second argument is, so it just completed here. The second argument is the file or files that you'd like to bulk load into the collection. And the third argument tells you something about the structure of those files. So here it's just saying that the values are separated by the new line character. And so we did this once for station information and once for station status. So if I do account star here, we can see we have 939 stations. And then for our status records, we've got 20,000 status records. And if I select out some of these station records, you can see down here that I've got 900 rows that look like that object that I just showed you in the PowerPoint slide. Okay, so now we're going to do a query that accesses these 2 collections. So here I'm doing a select from station status, and I'm projecting out the station ID from the JSON and also the number of bikes available. And then I'm grouping them by the station ID. And I'm projecting out the station ID, the station name, which I'm getting from a join that goes back to station information, and then the min, the max, and the average bikes available during this time period for this data. So if I run this, we see the result down here. So I've got the station ID, the name of the station, which tends to be like the intersection, I guess, that the station is on, and then the min, the max, and the average bikes available that during this period that we have the data for. Okay, so now I'm going to take this same query and I'm going to go into a machine learning notebook and show how we can create a bar chart over this data. Before I do that, I'm going to create a view for this query just so I don't have to retype all this when I get there. So just real quick. So this is the same query basically here, but I just tacked on a create view. I'm creating a view called station stats. Okay, so the view is created. And so now if I were to select from the view, we should see the same thing. And there it is. Okay, so now we're going back to the database console, and I'm going to click on this link down here for Oracle Machine Learning Notebooks. So it's starting up the SQL Notebook server. It's very fast once it gets started, but sometimes it takes a few moments to start. So basically, when we get in there, what we're going to do is we're going to query this view we created in order to create a bar chart showing the number of bikes that were available during this period. Okay, so I'm starting out by just doing a select all. And we get a result that looks like we saw a minute ago. So I'm going to refine this a bit. I'm just going to select the name, the min, and the max. Okay, so let's turn it into a bar chart. And I want to add the min and the max to my bar chart. But this is too much data to look at, so let's explore it a bit. Let's say we only want to see stations where the max available is greater than 25 at some point. It's a little bit better. Let's say we wanted to see stations where the max and the min differ significantly during the period. And that's better. Now we're down to 6 stations. I'm going to add an order by. Okay, so now we can see we've got, for each of these 6 stations, we've got a bar chart showing the minimum bikes that were available and the max. So I'd like to call your attention here to Fulton Street and Broadway. Here it's showing me that I've got a minimum of 12 bikes available during this period and a maximum of 32. And I want to make it clear that this station stats is a live view over my JSON collection. So I'm going to go back to Postman for just a moment. And I'm going to access this station status collection. And I'm going to insert a new data point. So station ID 319 is for Fulton and Broadway. I looked it up in advance. And now instead of 12, I'm telling it, no, there was actually, at some point, there was only 2 bikes available at this station. So if I send this, now it says that was successful. Now if I go back and hit refresh here, now we see Fulton and Broadway says a minimum of 2 bikes. So if I can do this again, let's say now there's 100 max. Come back here, and now it says there's 100 that were available during this period. So this is very much a real-time analysis of our JSON query. So this concludes my quick tour of the JSON facilities and the autonomous database. With HAD, you really do get the best of both worlds. You get this flexible, fast NoSQL style application development. But at the same time, you don't lose things like SQL transaction, advanced security features. You get elastic storage and compute while still being able to support real-time analytics over your data. And so again, anything that you've seen here, you can try in the free tier of cloud. If you're working with an always free instance, you can select ATP. All the JSON features are available there. And it isn't a trial or anything like that. You really just get a database for free forever. So there's really not much risk here. So I hope this encourages you to give it a try. So at this time, I'd like to answer some of your questions. If you haven't already, feel free to ask questions in the Q&A chat. So the first question is, what languages are supported for SOTA? So we have Java drivers. We've got Node.js, JavaScript. We've got Python. We've got C. We've got PL SQL. I think that's it. Maybe I'm missing 1 or 2. I'm not sure. But that's if you click through these links that I have on this slide here, all that information will be there. The next question, can you create indexes over JSON data? Yes, we support functional indexes, so you can create indexes over specific attributes, and those will be used and picked up when you're doing these query by example filters that you saw me do at the beginning. And we also support full text indexes. You mentioned that the JSON column stores binary JSON. What binary JSON format is it using? So we have a binary JSON format that we've created. We call it OSIN, and it's highly optimized, so it's efficient to read, and it also helps ingestion, retrieval. It helps queries. It helps updates. We've actually got the talk today is kind of high level. If you're interested in the low level technical details, There's a conference called VLDB that's going to be published, I think, in a couple months, and we have a paper that will be appearing there, and it goes into all of the low-level technical details on what we've done here and why it works well. Let's see. What are the typical architecture patterns for using AJD? Basically anything goes. There's a lot of different patterns out there. One that's increasingly popular is using like a three-tiered architecture with Kubernetes to manage your application nodes. So if you go back to this Moose Shop example that I mentioned, and that's linked on that slide. Oh, I have to resume share here, hold on. They kind of talk about it here. So if you have an app fully deployed in the cloud, you can deploy multiple compute nodes in the same data center that your autonomous database is running. And you can have Kubernetes and manage those instances and make sure they keep up and that you have resiliency. And then you can put them all behind a load balancer to support efficient scale up of your apps. But really, we support any application architecture that you would want to use. Let's see. Also, that if you wanted to build an application, the other option that we have that's very popular is Apex, if you were in the previous section in our track. So you can do like low code development as well using Apex over your JSON data. So you can get to that through the database console. So where we clicked machine learning notebooks, above that, there's a card for Oracle Apex. And so you can go in there and do things like it's aware of collections. So you can do things like load your JSON data from Apex into a JSON collection and build interactive views of your JSON data without having to write much code. You can really have something, I've done it, have something up and running in just moments, a production ready app. Okay, so I'm being told that that's all the time that we have for Q&A. Please join us for the next sessions. You have two options. You've got building a simpler, reliable persistence layer for microservices with Sanjay Goyal and Paul Parkinson. And then you've got achieving hyperscale with Oracle Autonomous Database with Maria Colgan. And if you want the agenda, the link's given here on the slide, developer.oracle.com/devlivedb. Again, thank you very much for joining me, and thanks.